We have another example on the board. Please notice that this time we have given voltage source in form of the cosine equation. What we're supposed to do first, we're supposed to convert cosine to sine. Remember, anytime you want to convert cosine equation to sine equation, you're supposed to add 90 degrees to the angle. So negative 30 degrees plus 90 degrees is going to give me 60 degrees. So I'm going to write voltage source is equal 10 sine, open parenthesis, 2 times 10 to the 7t plus 60 degrees volts. I'm supposed to find first Z total. You can find any other quantities if you can, but I'm going to start from Z total. Please notice that we have given resistance and we have given power factor. The formula for power factor for the parallel circuit is simply power factor equals cosine theta, and this is also equal Z total over R. Okay, I'm looking for Z total. So in order to find Z total, I'm supposed to simply rewrite this formula as power factor equals Z total over R, where if you are going to use algebra and solve this formula for ZT, you are going to have Z total equals power factor times resistance, where power factor is equal 0.7 times the resistance 400 ohms. This is equal 280 ohms. Okay, so this is the magnitude of my total impedance. But in order to make this answer complete, we're supposed to find the angle. So in order to find the angle, I'm going to use this part of the formula for power factor. Power factor is equal cosine theta. In order to find angle theta, I'm supposed to simply write theta is equal inverse cosine of my power factor, where this is equal inverse cosine and power factor is equal 0.7. It will give me angle negative 45.57 degrees. This is my angle theta. So I can right now write Z total is equal 280 ohms and angle of negative 45.57 degrees. Okay, so this is my Z total. Okay, and this is complete answer because I have the magnitude and I have the angle. Now, in order to find x of c, I'm supposed to find first Y total. Okay, so total admittance is equal 1 over Z total. This is equal 1 divided by 280 ohms and angle of negative 45.57 degrees. This is equal 3.57 millisiemens and angle of 45.57 degrees. Next, we're supposed to convert polar form to rectangular form in order to find conductance and the capacitive susceptance. So convert this to the rectangular form, and you're supposed to obtain 2.5 millisiemens plus J 2.55 millisiemens. The real part of my complex number is the conductance, G, and the imaginary part is nothing else, just the capacitive susceptance. So FBC. But we're supposed to find the capacitive reactance. In order to find the capacitive reactance, I'm supposed to write the formula X of C is equal 1 over BC, which is equal 1 divided by 2.55 millisiemens. And because I prefer to work with polar form, instead of J, I'm going to write angle 90 degrees. So this is equal 392.15 ohms, an angle of negative 90 degrees. So this is my capacitive reactance. Next, I'm supposed to find the capacitance, right, in my parallel circuit. In order to do so, I'm supposed to use another formula for capacitive reactance. X of C is equal 1 over omega C. Okay? I'm supposed to solve this formula for C. So C is equal 1 divided by omega times X of C, which is equal 1 divided by omega 2 times 10 to the 7, of course, radians per second, times X of C, which is equal 392.15 ohms. So the capacitance of the capacitor, okay, C is equal 127.5 picofarads. Next, we're supposed to find the total current, because we found Z total and we have given voltage source. Okay, we can find very easy I total. I'm going to use simply Ohm's law. I total is equal voltage source over Z total, where voltage source is equal 10 volts and angle of 60 degrees over Z total, which is equal 280 ohms and angle of negative 45.57 degrees. This is equal 35.71 milliamps and angle of 105.57 degrees. This is my I total. Next, I'm supposed to find the current which goes through the resistor and current which goes through the capacitor. Again, I'm going to use Ohm's law. So I have IR is equal voltage across the resistor over resistance. But someone is going to say voltage across resistor is not given. Voltage across the resistor is given. Why? Because this is parallel circuit. In parallel circuit, the voltage across each component is the same. That's why I'm supposed to write voltage source is equal to voltage across the resistor, and this is also equal voltage across the capacitor, which is equal 10 volts and angle of 60 degrees. Okay, so that's why my VR is equal 10 volts and angle of 60 degrees. I'm supposed to divide that by R, which is equal 400 ohms. This is equal 25 milliamps and angle of 60 degrees. Next, we're supposed to find the current which goes through the capacitor. So if IC is equal voltage across the capacitor over the capacitive reactance, where VC is equal 10 volts and angle of 60 degrees over X of C, which is equal 392.15 ohms and angle of negative 90 degrees. So current IC is equal 25.5 milliamps and angle of 150 degrees. Like always, we are going to verify our answers. I mean, the values of these two currents by using Kirchhoff current law. Kirchhoff current law says that if you are going to add the currents which go through the capacitor and resistor together, you're supposed to end up with the total current. So I have I total is equal IR plus IC, where IR is equal 25 milliamps and angle of 60 degrees plus 25.5 milliamps and angle of 150 degrees. Okay, so at the map you're supposed to obtain the value of 35.71 milliamps and angle of 105.56 degrees. Now you're supposed to compare this answer with this one. If they are identical or very close to each other, means that our calculations are fine. So the difference is just 7 and 6. So this is a very small difference, so we can say that these two answers are identical. So far so good. Next, we're supposed to find the true power. Okay, P true is equal 1/2, and I'm going to use the formula with current, IR squared times resistance. Please keep in mind, because we had voltage peak, we found the currents which are also going to be peak, because when you want to find a current using voltage peak, automatically current become peak. So that's why I'm going to use power formula with 1/2 at the front. So I'm going to have 1/2 IR is equal 25 milliamps raised to the second power times the resistance, which is equal 400 ohms. This is equal 125 milliwatts. And this is the true power in my circuit. Next, we're supposed to find the reactive power. QC is equal 1/2 IC squared times X of C, which is equal 1/2 times current which goes through the capacitor, and this is equal 25.5 milliamps raised to the second power times X of C, and we found X of C, and this was equal 392.15 15 ohms. This is equal 127.49 millivolt amp reactive. This is the reactive power in my circuit. Next, we're supposed to find the apparent power. Okay, so S is equal 1/2 I total square times Z total, which is equal 1/2 times I total. We found this is equal 35.71 milliamps raised to the second power times Z total, 280 ohms. This is equal 178.52 millivolt ampere. This is the apparent power in my circuit. Next, we're supposed to find the series equivalent circuit. So what we're supposed to do, copy down Z total. Z total was equal 280 ohms and angle of negative 45.57 degrees. Next, we're supposed to convert the polar form to rectangular form. And you're supposed to get 196.01 ohms. We have minus J 200 ohms, where the real part of my answer is the resistance RS, and the imaginary part is my X of CS. But the problem is also asking me for the capacitance of the capacitor in my series equivalent circuit. So you're supposed to use the formula for capacitive reactance. So you're supposed to write X of CS is equal 1 divided by omega CS. If you are going to solve this formula for CS, you're supposed to get CS equals 1 divided by omega times X of CS, which is equal 1 divided by omega is 2 times 10 to the 7, 2 times 10 to the 7, of course, radians per second, times X of CS. And we found that X of CS is equal 200 ohms. Okay, I'm going to continue over here. This is equal 250 picofarads. Okay, we found the capacitance in my series equivalent circuit. Now we can draw the series equivalent circuit. So we have voltage source, which has voltage 10, sine, omega, and phase angle. We have resistance RS, which is equal 196.01 ohms, and capacitor C with the capacitance of 250 picofarads. Now we can say that the problem is solved.